Guys, today our topic is Ether channel. So yesterday we had discussed spanning tree. So can anyone explain the what is the requirement of spanning tree? Why we need a spanning tree?
To avoid the
Can anyone
loops.
which loops? Which loops? To avoid the loops. Okay, fine.
Ethernet network.
Which loops will avoid with the help of spanning tree?
Um, in the network of layer 2.
I mean, between the
Yeah, so
devices.
Between the
yeah,
devices, like which acts like bridges.
where
Hmm.
they will be continuously broadcasting the messages. So
Okay. What is switch? Fine. What is a switch?
It's a layer 2 device.
yes,
It is used to connect the devices and hosts.
Hmm. Okay, what switch will do?
it will broadcast the message.
Okay, switch will broadcast the information. Okay. So in between two switches, if I am using the only one link, so here we have a connected host and host. So host generates some traffic. So which traffic he wants to communicate? PC1 wants to communicate PC2. So this is switch and we want also switch. So this one he wants to communicate PC2. Then what is the issue? Switch what it will use? Some frames in data links layer. What will be generate frames? So switch will generate the frames. That frame packet, whichever the receiving interface excluded that. Apart from that, it will be broadcast. It will be sent to entire devices. All the connected ports. How many connected ports? It will be sent those many ports. So before for that, it will be learn MAC address. It's multicast. So once the learn MAC address, then it will be do the unicast. So switch what it will do? Broadcast the information. Basically, switches broadcast the information, broadcast the frames. So if one link is there, then no issue. If we have a redundancy path, if this link goes down, then we had a issue. So that is the reason we required a redundancy path. If one link goes down, we have a redundancy path. We can easily communicate with the help of another path. So here no issue. So by default, STP is enabled in Cisco switches. So what it will do? So whenever the frame originated, it will be there will be a create the loop. How the loop will be occurred here? So it will be receiving interface. So here we have a two ports, right? Two are multiple interfaces we are connected. So these all are the redundancy path basically. So these all are the redundancy path. Whichever the sending excluded of these, apart from that, it will be sent entire path, entire the interfaces. So it will be received. Once it will be received, it will be sent again the same packet, same frames to that switch only. So it will be received and it will be sent again, and it will be received and it will be sent again. So sending and receiving the loop is originated in between switches. So for this loop, how will close that loop? How will remove this loop? With the help of STP protocol, spanning tree protocol. So spanning tree, it's a layer 2 protocol. It's a layer 2 protocol. So we'll avoid here with the help of spanning tree protocol, STP protocol, we are avoiding L2 loop. L2 means switching. We are avoiding switching loop. So what is the requirement of STP? Got it or not?
Yes, like
Yes, we are avoiding layer 2 loop with the help of STP. And 1 hour. Without. Okay, fine. See, so we are using only one path. Whenever we are using the STP, here we are using only one path. So then here this path is waste and this path also waste. This connectivity also waste. So for that, what we will do? For the here, the two switches are connected to each other. We have a multiple redundancy path in between switches. This is a switch 1 and switch 2. So if no redundancy path, not at issue, no loops occurred, STP loops are not generated. If we one path is goes down, then we have a issue. So we have a another issue, another path, and in real time, it will be happen likewise only. We have a redundancy path up to 4 links. So this is down only. This is also only whichever the root bridge having forwarding path, forwarding state. After then, apart from that, see, it's a root bridge. It's a root bridge, and this is a non-root bridge. Non-root bridge means it's a normal switch, normal switch, non-root switch, non-root bridge. So root bridge having forwarding state, all are these forwarding interfaces. So those are the DP designated ports, and all are these all are designated ports only. And these are only one is a root port. Apart from that, all are the blocking state, alternate port. These all are alternate ports. If you want, you can verify at bracket tracer. Two multi-layer switches I have taken here, and 4 interfaces connected. These all are the redundancy path. Only one path it will be up. So yesterday we discussed spanning tree, how it is working. So now it will be which state it is. Show spanning tree. These all are the blocking state. Only one is the learning state. Check here. Enable. Show spanning tree. These all are the DPs, designated ports. It means these all are forwarding states. Forwarding means DP. State is forwarding and port role is designated port. Then this is a root port. Only one is a root port. Apart from that, all are the blocking state. So here we are wasting our resources. So that is the reason we are not achieve our load balancing. If we want to achieve the load balancing, so we have a protocol that is ether channel. Ether channel. With the help of ether channel, multiple physical links, it will be convert into one logical link. These all are the 1, 2, 3, 4. These all are the multiple physical links. It will be convert into one logical link. That is a port channel or ether channel. Understood? What is the ether channel? These are all are the, so here we are not using our resources 100%. So even though we paid everything for this link, for this link, for this link also, but we are not using. So that is the reason we have a ether channel. So 100% will use every link in our real time. So that is the reason we have a port channel, that is ether channel. Any questions? Actually, ether channel, it is used to aggregate. This is a aggregate multiple physical links. It will be aggregate multiple physical links into a one logical link. It will be aggregate multiple physical links into a one logical link. That is, we call it as a port channel. So it is used to aggregate multiple physical link into a logical link through which we can get a higher bandwidth and redundancy as well. This logical link will be called as a ether channel. So basically, so we have a four interfaces here. So IP interface brief. This is the four interfaces we are using now here. So each interface show having speed or bandwidth. So interface fast Ethernet 0/1. So this link having the 100 Mbps and this link having 100 Mbps, 100 Mbps, 100 Mbps, 100 Mbps, 400 Mbps at a time we can use. At a time we can use. So here, so these are the uplinks actually. Uplinks real time will connect to the uplink only. Here we have only two uplinks. So gigabit 0/1, 0/2. Mostly we'll use these links only, either channel for part, because see, it's a real-time example. Multiple users are connected here. PC1 originated. Here we have 100 Mbps link, 100 Mbps link, 100 Mbps link, 100 Mbps link. So here we have 400 users. Let's take 100 user only first time. 100 users we have here. Each user originated 1 Mbps link traffic. 1 MB link traffic. So if we are not, now forget about these links, these three links. Here we don't have any links. So PC1 originated some traffic, that is 1 Mbps link. So he'll get the same traffic, same uplink for him. He can communicate. So at a time, 100 users are originated the same traffic. Then each link there we are getting the same traffic. If 100 users are not using the same bandwidth. So 10 users only using the bandwidth now. Then each user will get 100 MB link. If at a time 100 users they are using the same link, then they will get 1 Mbps. Then delay will be happen. So if you are using the 3 links here, 4 links, then this 100, then each user will get minimum 4 MB, 4 MB. Likewise, we can share our bandwidth also. So for that, whichever you are using the interfaces, those should be matched. So that is what here. Bandwidth, we can get higher bandwidth and redundancy as well. So we'll get the redundancy as well and we'll get the higher bandwidth. I have given the simple example for your understanding purpose. It is not a proper, but it's small example for your understanding purpose I have given. So what is the requirement for that? So this logical link will call ether channel. Actually, this link is called ether channel. We can use this concept on Cisco and non-Cisco devices also. It's not only for the Cisco proprietary. We can use non-Cisco devices also for entire whichever Aruba, Palo Alto, those devices also we can use the same concept, and we can aggregate maximum 8 physical links. So I have taken here 4 links only, but up to 8 links we can use. One to another 4, add on 4 links. This many links we can use the ether channel. Up to 8 links we can aggregate. Up to 8 links we can aggregate the ether channel. So the requirement of ether channel here, speed, whichever the you are using the interface. For example, fast ethernet speed is 100 Mbps, and ethernet link speed is 10 MB. FA fast ethernet link is 100 Mbps, and 1 gig is equals to 1 gig only. So here we have a interfaces as we discussed. So here this is a gig interfaces. So this is a basically in real time we'll use uplink. So uplink it means, so this is your internet and it is your core switch. In between we'll use, this is a uplink. We call it as a uplink. For that we'll use. So for that, duplex also match, full duplex and half duplex, whichever you are using. If you are using the full duplex, then duplex should be match. Here you can check duplex. If both end duplex should be match. And Ethernet standard must match. If you are using the fast Ethernet one end, and you should have to use second and also fast Ethernet. In between two switches, you should have to use the same. If in between the two switches, if you are using Ethernet, then use Ethernet standard. Otherwise, if you are using fast Ethernet, then use fast Ethernet. If you are using gig link, then use gig link. If you are using serial, then it will be not support for serial anyways. So it will be support ether channel only. So that is the reason ether you can get here. The serial links it won't support. So Ethernet standard must match. So trunk encapsulation protocol must match. If you are using here ISL, two types of trunk encapsulation methods we have: inter switch link, and one more is dot one q 802 dot one q. So both end trunk encapsulation method must match. This is a trunk. So switch port mode trunk, whenever you are using switch port mode trunk and switch port encapsulation dot one queue, that should be match. Switch port mode, whichever you are using. If you are using the access, then both end access should match. If you are using trunk, then trunk should match. Both end trunk encapsulation should be matched. And trunk allowed VLAN. If you are allowing some VLANs, so those should be matched. If you advertise some VLAN is allowed VLAN 10, that VLAN you have not allowed here, then the encapsulation it will be not done. That ether channel not form in between for that VLAN. This is a requirement we should have to follow. Speed must match, duplex must match, ether channel standard must match, trunk encapsulation must match, and trunk allowed VLAN must match. And it will actually ether channel will use some load balancing. What is the load balancing? Where it will be used basically? So it's a switch and so multi-layer switch and another multi-layer switch, both are connected to each other. Here I am taking one, it's a multiple path I am taking here. They are connected, some users. So how the load balancing will perform? Switch 1 and switch PC2 and PC3. First PC originated some traffic. So here we enable the ether channel in between. So PC1 originated some traffic. So here we have a four physical links. Even though if you created the port channel also, that is, it will look like PO1 or 10 port channel, and here also port channel 10. Even though it's a logical interface, but traffic it will be move physical interface only. Other 0 by 1, 0 by 2, 0 by 3, and 0 by 4. It will be traffic will forward based on the interface only, physical interface only. So how it will be elected? Here it is a load balancing. Sometime this user also originates some traffic. This user also originates some traffic. And more user is there, that user also will originate some traffic. So here he should have to select one path, right? So how it will be elect the path based on the load balancing only. Based on here we have a load balancing, ether channel load balancing. Based on ether channel load balancing, they will select the physical path. Based on that, they will forward the traffic. So for that, here we have a 9 load balancing methods, 9 load balancing steps. First, it will be check source MAC address, destination MAC address, source and destination MAC address, source IP address, destination IP address, source and destination IP address, source port number and destination port number, and source and destination port number. So this is the L2 traffic, and this one is the L3 traffic, and this one is the L4 traffic. whichever you are originating traffic, based on that, it will be elect the path. So if this user originated some IP to IP connectivity, based on that, it will be elect the load balancing. Then it will be select the path. So actually, we have a mainly two types of ether channel here. One is statically will configure. Another one is dynamically will configure. Two types of ether channel. One is static, another one is dynamic. For ether channel, we have a two types. One is static and one is dynamic. In the dynamic also, again we have a two types, PAGP and LACP. PAGP and LACP, two methods we have, PAGP and LACP. Ether channel, we have a two types. One is static here. Static means statically we are configuring. So the mode is on. And here we have a dynamic two types of dynamic methods. Here we have one is PAGP and another one is LACP. Dynamic. There are two methods we have. And PAGP stands for port aggregation protocol. And LACP, link aggregation control protocol. Link aggregation control protocol and port aggregation protocol. So basically this one is the Cisco proprietary. PAGP, it's Cisco proprietary, it's a open standard. It's a open standard. The open standard protocol. And PAGP, it will be up to 8 links we can aggregate, up to 8 links. But here we can aggregate So PAGP, it's Cisco proprietary. We can aggregate 8 number of links in case of PAGP. There are two types of modes. One is desirable and another one is auto. One is desirable and one is auto. And a link state in link aggregation control protocol, we have up to 16 links we can aggregate, but even though in that 16 links, 8 links only active and another links, 8 links will be passive mode. Remaining 8 links will be standby mode. So there we have two types of mode, active and passive. Here, so what is the issue actually? So here we have active and passive mode. Here we have desirable and auto. So I'll show you in lab. So desirable and auto, here we have two modes. For that desirable and desirable, whenever you are configured desirable, then aggregation will be formed. If you are using the auto means there it won't form the aggregation. So one side desirable and another side auto, it will be from the aggregation. So here the mouse issue. Fine. Guys, if you have any questions,
No.
so so here we discuss, as we discussed today, ether channel having two types to we can configure. One is like static. First we'll configure here static mode. For that, what we'll do, and apart from that, what we'll do, we'll configure the entire thing. I'm taking here one multi-layer switch and This one is a static, and here we'll use PAGP, and here we'll use LSCP. Meanwhile, we discuss the modes also. So in spanning tree, some ports will be blocked here. So which one is the root bridge? First we'll check. So spanning tree. So this one is the root bridge. If this is, you will not get a root bridge, then some reduce some priority, definitely you will get you will convert this as like root bridge. So root bridge election, it's like which one is having the less MAC address, before that less priority and less MAC address, it is the root bridge. Whichever having the least MAC address, least priority, if priority is high, then MAC address, which one having the least MAC address, that will be root bridge. So it is elected as a root bridge. That is the reason all are the port roles are DP designated port, and state is forwarding state. Rikvita,
Yes, Salim.
what is the states? What are the states in STP?
Forwarding state, blocking state, disable state, learning state, listening state.
Sequence.
Oh,
Sequences.
okay. First blocking state, then listening state, then learning state, then forwarding state, and disable state.
Bhavana,
Yes, Salim.
RSTP states. RSTP states. What is
Yes.
RSTP?
Rapid rapid spanning tree protocol.
Hmm.
Blocking, learning, and forwarding it. It has only 3 states.
Okay,
Yeah.
fine. Now, why it is elected as a root bridge?
Because it has the lowest priority.
Are you sure? Priority is here. This switch 32768, and this switch also having the 32768, and this switch also having the 32768. Priority is same for all the switches. For all the switches, priority is same.
But we need to check MAC address too, right?
MAC address is 2595. So we have to check the MAC address, whichever the having the least MAC address. So that will be elected as a root bridge. So this is the content is here root bridge, and this one is the local switch content, local switch. So local switch having the MAC address is this one, and this is a root switch, root bridge. So fine, ether channel configuration. So this one is the two types we can configure. One is static and one is dynamic. Dynamic, we have a two methods, PAGP and LSCP. PAGP is Cisco proprietary, and LSCP open standard protocol, and PAGP up to 8 links we can configure. Here I have taken 2 links only, up to 8 links we can aggregate, and LSCP having it 16 links, but in that 16 link, 8 links only active. Apart from that 8 links, we have a standby state. So here we have two modes. One is desirable and one is auto. And here we have two modes, that is active and passive modes. So how we'll configure it? Port channel. Just for that, configure here 0 by 1 and 0 by 2. For that, interface range fast Ethernet 0 by 1 to 2, and I'll create the port channel. For that, channel, here we can configure channel group as well, channel protocol also. Protocol means directly you can select the protocol here. From here, LSCP and PAGP, you can select whichever you need. So for that, we are not configuring port group. In that group, select the group here in between the range 1 to 48 to 10, and mode. Select the mode. Here it is showing active, this one, and active and passive. These are the LSCP modes, and auto and desirable. These are the PAGP modes. And on means we are manually configuring port channel. So on. So once the port channel, whenever it will be create, the port channel link interfaces will be goes down and it will be convert to up. So here config terminal. So whenever you are configuring statically, both sides you should have to configure statically. Otherwise, the port channel will be not aggregated in between. So channel group, interface, range, fast Ethernet 0 by 1 to 2. Channel group, channel group 10 I have taken here. So group mismatch also no issue. The port channel will be created. On. So once the ports will be down and they both will be up. So now you can check here. Both interfaces are up. Wait for a while. Just check span in the store spanning tree. So port channel is created. That is, earlier we have a two links, but now you can check here. PO port channel 10 we have, that is root port. So here also it will be take spanning tree will work. Whichever having the designated port, root switch having the designated ports, and non-bridge non-root switches those having the designated ports. So here you can click show panning tree. The port channel we created, that is fast Ethernet 0 by 1 and 0 by 2, that is shared media, not a point to point. Here you can check share media. The port channel is like it will be. So it is created the port channel for better understanding purpose. So IP interface brief, you can check here. So here the port channel is created. You can check show interface port channel 10. It's a logical interface detail. So it is 200 Mbps. So 100 is one link, 100 is one link. So the bandwidth is added here. That is 200. So interface ether channel. You can check here. So this is L2 ether channel, and we have a L2 ether channel as well and L3 ether channel also. So for here we have taken two links only, 0 by 1 and 0 by 2. That is the reason here it is showing two links, and maximum up to 8 links we can aggregate it, and port channel created, that is manually we are created. That is the reason it is not showing any protocol name. So that is the reason here not showing any protocol name. Channel group is 10. Ether channel summary. Check summary. So here SU, it means layer 2 in use. Layer 2 we are using. If RU, it will be show means R, here you can, yes, R means layer 3. We have two types of ether channels, again L2 and L3. So if L3, if you are configuring in between, so there is no need to do trunk port and all. So here you can give the IP addresses. For that, how config terminal, how you assign the IP address to interface fast Ethernet 0 by 1, or if just IP address, likewise you will configure it. So here if you want to configure the IP addresses, for that interface port channel 10 and IP address, likewise you can configure it, IP address 192.168 something. For that we have to use no switch port. By default switches having the L2 ports. So that is advanced topic, even though leave it. You have to know, that is the reason I have explained. So ether channel summary. So this is a L2 port channel here showing. So here two ports here we can see here, 0 by 1 and 0 by 2. So if you want to check this load balance, show ether channel load balancing. So here we have IPv4 and IPv6 and source MAC address. Source MAC address. So based on this, load balancing will be happen. Here it is not showing the port based, the post port basis, source port and the destination port, and source and destination port. That is not showing, but it will be advanced level. So packet tracer, that is the reason it is not showing. So show. So even we have not configured. So we'll configure in between the PAGP. Any doubts in static? How we configure the static? Any doubts? Yes or no?
No, Ali.
So now check again. Here we are configuring the same thing only for port channel. So better we'll configure. I have taken two switches, one link, two, three, four links. Enable. So here you can check four links are there. Fast Ethernet 0 by 1, 0 by 4, 0 by 3, 2, 0 by 3. So these are our learning state. Learning blocking state, one only forwarding state, that is root port 0 by 1. Based on port, it will be elected as a root port. So this is our root bridge. Enable. So spanning tree will configure here PAGP. So config key. For this will configure trunk port, switch, interface, range, fast Ethernet 0 by 124, switch port, mode, dynamic, desirable. DTP I have configured here. Dynamic desirable. One is DD and up. This one is the DA. Show interface fast Ethernet 0 by 1. So can check here. This is a switch port. Mode is dynamic auto. So that is the reason I have configured here DA. So you can check show interface trunk. So trunk is an established in between the switches. So we'll configure here now port channel, config terminal, interface fast Ethernet, interface range fast Ethernet 0 by 1 to 4, switch port. No. For that we have to take ether channel group. If you are to take ether channel protocol also. For that we have a two protocols we can configure, but we'll take it as a group only now. Channel group will take 20 and mode is here. For PAGP part, one side you should have to make it as a auto and another side desirable. If both side desirable, then ether channel will form. If you take one side is auto, one side is desirable, then also aggregation will be formed. If you are taking the both side auto, that time it will be trying to establish a aggregation, but it won't. Though so auto mode is there, then it will be not formed. So same in passive and active. If passive both end, then aggregation will be formed. One side is active, one side is passive, then also aggregation will form. One side is active, another side also active, then it will be not form the aggregation unconditionally. Here it is not form the aggregation. Interface. Interface range, fast Ethernet 0 by 1 to 4. So we created channel group mode. Channel group 10 and mode is, so I'll take both and auto. What it will happen? Auto. Both and I have taken the auto. So definitely channel group, it won't form. See, still orange color only. They're trying to establish a aggregation, but they won't. So we'll change the mode in the switch. Before that, we'll use no command. desirable. So here you can check. We have a auto and desirable options. So here I'm taking the desirable option. So the channel summary, no ether channel is formed. Even though now you can check here, all are the ports. It will be moved to the green color. Once physical interfaces will be goes down and it will be up, then port channel will be up. Check port channel. We haven't configured anything, that is showing down only. Port channel is showing down. We got it here. Show spanning tree. Unconditional type is unconditional. Twenty is showing. 10 and 20 both I have configured, I think. Two groups I have taken. That is the reason it is showing unconditional. So here 10 is there and channel group is auto. So that is the reason it is showing the misconfiguration we did. That is the reason it's showing unconditional. So you can check here, two channel groups are established. One is down, it is showing, and one is up here, it is showing. The verification part we did. Got it or not? For working is, so whenever you are using the no port channel, it won't work. So you should have to, if you want to remove the port channel, interface port channel 10. So there you have to remove. Is brief. Now it is removed. If you are removing directly, it won't work. You try to remove the no with the help of no port channel, so it won't work. You have to remove likewise. IP interface brief. So here we have only one port channel and can verify show ether channel, that is PAGP mode. Show ether channel summary. Can check here. PAGP and SU means layer 2. Layer 2 in use. We are using in layer 2. Show ether channel load balancing. Verify it. Source MAC address, destination MAC address. It is depending on the traffic will be forward. Guys, I hope everyone got it though how to configure the Ether channel and what is the requirement the Ether channel, how to verify, how to troubleshoot the Ether channel. So, IP interface brief with this command, we can verify our port channel in real time also. So show spanning tree. Here we'll get the port channel is share media. So I hope everyone got it. So your task is configure LACP. So for that, I'll give you the brief. First, select the interface range. That is your task. Today task is you have to configure this entire topology. I have configured here side by that is PAGP, but you should have to configure here. I'll show you some brief. Config T, interface range, select the range from 0, 5 to 6 and first Ethernet FA and channel group is 30 and take mode. If you're taken here passive one end and passive both end, then the aggregation will be formed, port channel will be formed. If you are taking both end active and active, then aggregation will be not formed. If you are taking one side as the passive, another side as the active, then aggregation will be formed. Are you ready to do this task? Everyone?
Yes, Salim.
Fine. I'll stop the recording.